Okay, in this example, we determine whether the given lines are parallel, skew, or intersecting. Skew means they're not intersecting or parallel, and that can happen in space. Line 1 is given by these parametric equations. X equals 1 plus 2t, y equals 3t, and z equals 2 minus t. Line 2 given by x equals negative 1 plus s, the parameter is s for line 2, y equals 4 plus s, and z equals 1 plus 3s. Okay. The direction vectors will tell us whether or not the lines are parallel. If they're not the same line, but they have the same direction vectors, it means the lines must be parallel because their direction vectors are parallel. So if you look at the direction vector v1 for line 1, you can pick it out as the coefficients of t. So 2, 3, and negative 1 would be our a direction vector for line 1, and v2, a direction vector for v2 would be 1, 1, and 3. The coefficients of s. Now, there is no scalar. I can multiply v2, say, for instance, and get v1. So if I multiplied v2 by, say, 2, I'd get a 2 for the first component like I have here in v1, but I wouldn't get a 3 in the second component, and I certainly wouldn't get a negative 1 in the third component if I multiplied through v2 by 2. So we can see just by looking at these guys that v1 is not a scalar multiple of v2, which means they're not parallel. If they're not scalar multiples, the two vectors are not parallel. Okay, let's see if they intersect. That's the next thing you're going to want to check. If they intersect, then there's got to be a t and an s value that produce the same point, the intersection point, which means I should be able to set x values equal and set y values equal, and the x values in terms of t and s, and the y values in terms of t and s, to get a system of equations that I can solve to find this intersection point if it exists. And if the values we get satisfy the third values for z in both lines, then we'll know it's a true intersection point. If not, then there is no intersection point. Okay, so the system of equations we're going to create here. 1 plus 2t, we're going to set this x value in terms of t, or first component in terms of t, in L1 equal to the first component in terms of s. When I say component, I'm thinking of it as a vector valued function. The first value in terms of s, first component in terms of s in line 2, negative 1 plus s. And then the second equation would be 3t equals 4 plus s. So we solve this system, if possible. I think it will be possible, actually. Okay, so I could pretty easily get s from the top equation. So from the top equation, I can get s. Let's see, s is going to equal 2 plus 2t. All right, if I just add 1 to both sides, and then what I'm going to do is I'm going to plug this guy in for s right there, which gives me the equation 3t equals 4 plus 2 plus 2t. This is what I plugged in for s right here in parentheses. Now this is easy enough to solve for t. If I subtract 2t from both sides, that leaves me with t on the left side, and 4 plus 2 is 6. I get t equals 6, and if t equals 6, that means s equals 14 if I plug that in right there. So do these values of s and t satisfy the third equation so that we produce a point of intersection for those values of t and s. The third equations, I should say, plural. Okay, well, in other words, if I plug in t here, I better get the same z value. If we really have an s and t that produce a point of intersection, I better, oh, I don't know if you can see what I just pointed at, so let me go back up. If I plug in my t value here, my t value was, remember my t value was 6. If I plug in 6 here and 14 for s, the values I got for t and s when I solved the system, I better get the same z value if in fact there is a point of intersection. In other words, these t and s values should produce that point of intersection if it exists. But you'll notice if I plug in 6 here, I get 2 minus 6 for z. And if I plug in 3 here, I get 1 plus 3 times 14 for z. Not the same. I don't even need to do the arithmetic. I know that 2 minus 6 does not equal 1 plus 3 times 14. Does not equal 1 plus 3 times 14. So again, because these guys are not equal, we don't get the same z value for the t and s we found when we solved the system, so there is no point of intersection. So we know the lines aren't parallel. We know there's no point of intersection. They don't intersect. So that means they're skew. The lines are